Hi there. This short video clip is going to explain to you how to rationalize the denominator of fractions that have surds in them. Before we get there, let's start off with some simple fraction discussion. Imagine I had the fraction a half. If I asked you to generate an equivalent fraction to a half, that means a fraction that has the same value as a half but has a different numerator and denominator. Well, you might say to me, imagine I multiplied the top and bottom by 2, for example. 1 times 2 is 2, 2 times 2 is 4. Well, what have we done here? Well, 2 quarters, well, this fraction here has the same value as a half, but it's got a different numerator and denominator. Similarly, we could pick any number. For example, with a half, we could multiply the top and bottom by 11. 1 times 11 is 11, and 2 times 11 is 22. Again, what have we done here? We've generated a fraction, 11 over 22, here, that has the same value as a half, but has a different numerator and denominator, a different top and bottom. Okay, so moving on to rationalising surds. This is going to be an important idea. Mathematicians do not like when there is a surd on the denominator of a fraction, and at all times they try to remove that surd from the bottom of a fraction. This is called rationalising a fraction. I will ask you, what could I multiply the numerator and denominator, the top and the bottom of this fraction by? Well, you might remember my last video clip about multiplying surds. Imagine I multiplied the top by root 3 and the bottom by root 3, the numerator by root 3, the denominator by root 3. 1 times root 3 is simply root 3, and root 3 times root 3 is root 9. Well, what is the square root of 9? Well, that is 3, so this simplifies to root 3 over 3. What have we done here? Well, let's think back to what we've talked about previously. We've generated an equivalent fraction to 1 over root 3, but the surd's been removed from the denominator and is now in some form on the top, or the numerator. Okay, let's have a go at a few examples. This process, by the way, is called rationalising the denominator, and it's the process of removing the surd from the denominator of a fraction to keep mathematicians happy. Okay, example 1. 1 over root 7. Imagine multiplying the top, the numerator, and the denominator, the bottom, by root 7. 1 times root 7 is root 7. Root 7 times root 7 is root 49. But I know what the square root of 49 is. It's just 7, so this simplifies to root 7 over 7. Example 2. Imagine multiplying the top and bottom by the square root of 5. 10 times root 5, well, what's that? A mathematician just writes that as 10 root 5. Root 5 times root 5 is root 25. What is the square root of 25? Well, it's 5. So this simplifies to 10 root 5 divided by 5. But we can even simplify this further. What number goes into or divides into 10 root 5 and 5? Well, 5 does. So we could divide the top and bottom by 5, simplify our fraction, that is. 10 root 5 divided by 5 leaves me with 2 root 5, and 5 divided by 5 leaves me with 1. A mathematician would simply write that as 2 root 5. The very last example, we've got 10 over 3 root 5. This is different to example 2 because it's got a number in front of, a coefficient in front of the root 5. Again, all we have to do is multiply the top and bottom by that particular surd. Not by 3 root 5, but simply by root 5. Multiplying the top, again we get 10 root 5. 3 root 5 times root 5. Well, that must be 3 times root 25. The top again is 10 root 5. 3 times root 25. Well, root 25 here, that's just equal to 5. So this means 3 times 5, or 15. Now ask ourselves, what divides into 10 root 5 and 15? Well, 5 does. 10 root 5 divided by 5 leaves me with 2 root 5. 15 divided by 5 leaves me with 3. And this is the simplified version and the rationalised version of this particular fraction. Thank you very much.